So what we're looking at today is a short note on galaxies. So we're going to look at basically what a galaxy is, some of the main ones, and just some of the different types. So star-studded galaxies. So we currently live in the Milky Way Galaxy. That is the galaxy that Earth and our solar system are in, and you can see a picture of it in the background. Milky Way, I believe it got the name because it looks like spilt milk, or when you spill milk, that idea. One complete spin of the Milky Way takes about 225 million years. So similar how it takes the Earth to spin or revolve, rotate, it takes about 24 hours. To revolve around the sun, it takes 365 days. Well, for the Milky Way to spin, it takes 225 million years. And a galaxy, which is the Milky Way, or Milky Way is one example of them, the galaxy is basically a huge swarm of stars. So you can see in this picture all those little white dots and the different colors. They're all basically stars, and our sun is one of those stars. So in the Milky Way, our solar system is located on the Orion arm of the Milky Way. So you can see an example of that. You can see the Milky Way again, in that little arrow. You are here. We are in that circle. So that is where our solar system is in terms of the Milky Way Galaxy. The next nearest star to our sun, so again, remember the galaxy is a swarm of stars. So the next closest star is Proxima Centauri. And you can see on the image or the graphic, it's about just over 4 light years away from our current sun. The next closest galaxy, and what is basically the most distant object our eye can see, so what we can see with the naked eye, the most distant object is the Andromeda Galaxy. And again, you can see that example or that picture in the background. You may have seen images of something like this before, but that's the closest galaxy to the Milky Way. And we are seeing this galaxy 2.2 million years ago. So we're going to look at another example, and then in a later note, we'll kind of explain what we mean by that in a little bit more detail. So here we can see the Milky Way on the left. So that is where we are. And basically, to go from one end to the other in the Milky Way is 100,000 light years. And what a light year is basically the distance light can travel in 1 year. So I know that might be a little bit hard to see, but if we were to slow down, say like turning on a laser pointer, if we slowed it down really, really slow, you would see that the light's emitting out and coming out of it, and then it hits the spot on the wall that you're pointing at. However, if we, to us that seems almost instantaneous, but it really is just really, 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 really fast. So you can imagine how far light can travel if you shot it for 1 year or it carried for 1 year. So it basically takes 100,000 years for light to travel from one end of the Milky Way to the other. And for light from the Andromeda Galaxy to reach us on the Milky Way, it takes 2.5 million years. That's why the distance is 2.5 million light years. And in a later note, we'll look and break that down a little bit further into numbers that we can imagine. But the reason that we're seeing the Andromeda Galaxy 2.5 million years ago, we basically see with light. Right? Light gets rays are bounced off of objects, and that light then travels into our eyes, and that's what we see. That's how we can see things. Right? The light bouncing off of objects and then bouncing into our eyes. And you'll learn more about this in grade 10. So in order for us to see the Andromeda Galaxy, that light that's coming from it, that's going into our eyes, has traveled 2.5 million years, or it's taken 2.5 million years to travel from there into our eyes. But even though it seems instantaneous. So that light or that image that we're getting or we're seeing when we look at it is actually 2.5 million years old, which is a confusing concept if you really think about it, because everything we see it instantaneously. But again, that's because it's so close to us. This object is so far away, or this galaxy is so far away, that the light has taken 2.5 million years to travel and then enter our eyes. You could think of something, if you've ever watched Futurama, there is an episode where in 1999 they're playing a video or a TV show, and the signals get broadcast, and then it reaches another planet 1,000 years later. So that idea of sound waves taking time to travel before they reach something. So what's current to one thing is not current to another. So that's kind of the same thing with light, although it's a little bit difficult to see because we see everything instantaneously. So galaxy shapes. So not all galaxies are shaped the same. There we have a spiral-shaped galaxy. So this is a thin pinwheel with long curved arms. We have a barred spiral. So basically, spiral arms stick out of a central bar. So this is what the Milky Way is classified as. We have an irregular shape, which basically means there is no shape to the galaxy. We have a dwarf galaxy, which is 3 to 10 times smaller than some of the other ones. And again, remember, a galaxy is just a huge swarm of stars. So this is just a swarm that is 3 to 10 times smaller than the normal or average. And elliptical, which is an oval shape with old stars. So this is an example, or these are all the examples of the different types of galaxies. Let me bring up my laser pointer. So we can see the spiral galaxy over here in the bottom left. So we can see kind of a pinwheel shape with the arms spinning out of it. We have a regular shape in the middle. So again, it looks more, it's a cluster of stars still, but it doesn't form a distinct shape. We have our elliptical in the upper left. So again, we can see it's got that oval shape. I'm not sure if it's just because of the image or the resolution, but you can see maybe it looks a little bit dimmer. But again, it's got that oval shape. The barred spiral up here to the upper right, you can see that kind of central bar in the middle, or that cluster that's kind of almost like a bar, and then you got the pinwheel spins off of it. So hopefully you can see the difference between the upper right and the bottom left, even though they're both considered a type of spiral. And then down in the bottom right, we can see a dwarf galaxy. So again, we can see a slight cluster of stars. However, it does not appear to be as distinct or vibrant as some of the other examples that we see here, which again gives it that dwarf characteristic. So again, is just a quick note, just looking at the different shapes of galaxies and understanding what a galaxy is and two of the main ones.